Ratio of lengths. We're going to learn all about that first. Let's understand what a ratio is. It is simply comparing values. Take a look at this picture over here. This has 3 of something in red and 7 of something in blue. It looks like a cup. We'll just call it teaspoons. So 3 teaspoons of this red to 7 teaspoons of blue. 3 to 7 is how you say that. We can also express that as a fraction and write 3 over 7. Think about this. Look at, there's how many blue, how many yellow? Blue to yellow, 3 to 1. You can write it that way, or 3 over 1. And finally, one of the most common ways we see this is in a ratio that's called a unit rate. We see this a lot in miles per hour. How many miles could you go per hour? Yes, sometimes we can say that as well. Like on the last example, 3 per every 1, 3 blue per every 1 yellow. All right, let's get started. What is the ratio of the length to width? Well, the ratio of the length to the width. Let's see. What are we starting with here? What do you think? Well, yeah, look at the length. 3/4 to 3/8. That's the ratio of the length to the width. We could also write this in division here, 3/4 over 3/8, and so that would create a division problem. All right. And you do know if we are dividing by a fraction, we can then multiply by its reciprocal. It flipped upside down. So if we just multiply the numerators and denominators, guess what we get? We get 24 over 12, which is 2 to 1, which can also be expressed as 2 to 1. All right, let's take on another one. A board is 7/6 of a foot, and it was divided equally into 2 pieces. What is the length of each piece in feet? Well, we have 7/6 total. We need half of that, right? So let's divide it by 2. In other words, 2 over 1, which when we multiply by the reciprocal is 1 over 2. Multiply across the numerators and denominators, and you get 7/12 of a foot. The lengths of corresponding sides of 2 similar rectangles are a ratio of 1 to 4. If the area of the smaller rectangle is 0.6 square meters, what is the area of the larger rectangle? Now, this is an easy one since we're using a 1 to 4. Yeah, so we know the 1 is 1/4, or in other words, the bigger one is 4 times as big as the smaller one. So we simply need to take 0.6 meters squared times 4. And you guys know 6 times 4 is 24, right? But it's 0.6, so the answer is simple, 2.4 meters squared. Finally, similar triangles have corresponding side lengths in a ratio of 3 to 5. If the perimeter of the smaller triangle is 15 centimeters, what is the perimeter of the larger triangle? Okay, let's set our ratio. We've got the smaller one at 3, the bigger one at 5. Now we know the perimeter here is 15 centimeters to the smaller one. So here's another way to think about this. If my ratio is 3 to 5, and I know what the 3 is, 15, I just need to figure out what the 5 is. So now I'm just changing forms of the same ratio or fraction. So how do I get from 3 to 15? I multiplied by 5. What do I have to do to the denominator? Multiply by 5, and you're left with 25. The area or the perimeter of that triangle is 25 centimeters.